This is a topic that's really in the hearts of many people right now, and not because blockchain itself is very interesting, but because there's a lot of hype around cryptocurrencies. So let me quickly go into what exactly is blockchain about. I took some of these figures a couple of weeks ago, and it has since changed. So you can tell the volatility of cryptocurrencies. In fact, the last check this morning, the market capitalization of cryptocurrencies are at about $200 billion. And that's a massive amount of money, right? And what's unknown to most people is that besides Bitcoin, there are about 2,000 different cryptocurrencies in the world. 2,000. It's a massive number, right? And every week, as you look up, there's probably a few more ICOs that's being launched as well. Yeah. So all these, in fact, cryptocurrencies that's coming online have different usage and different purposes. And my intention, in fact, today is not to go into cryptocurrencies. My intention today is to talk a little bit about the platform that is underlying the cryptocurrencies, and that's called blockchain. In fact, blockchain as a technology is around for many years already. The first real implementation on a very broad scale is obviously Bitcoin in 2009. And that has shown itself to be very robust, surviving almost close to 10 years of public adoption. But what are the key areas about this underlying technology that we need to know? So I'm going to give probably 3 points. And if you remember these 3 points, you can tell yourself that you are a blockchain expert as well. And in a cocktail party, you can talk to people, I know blockchain, right? So my first point, right, is that blockchain essentially is a ledger. And what is a ledger? As accountants, we know a ledger is somewhere where you record transactions, you store records. But what's the difference between this ledger in blockchain and our typical ledger is that it's distributed. It means that it's not in a single location where the information is stored. In a typical ERP systems that we have, I always tell the client, right, that it's important to have an ERP. Why? Because for an organization that has many operations, the ERP serves as the single source of truth. And as accountants or as auditors, you go to that same place that you can get records consistently, that you can get records that applies through the organization. But blockchain is slightly different, right? There is many copies of the database that is residing in different areas, and this is why it's called a distributed ledger. One of the key benefits of a distributed ledger is resilience, right? There is no single location where it can be hacked or where somebody can go in and change the records as well. I'll come a little bit to that later, but first point, right? It is a distributed ledger and not a centralized ledger as you know your ERP to be. The second area, or the second point about blockchain is also that it is a programmable ledger. A lot of you would have heard of this term that's used very commonly. It's called smart contract. In fact, the word is quite misleading, right? Because a smart contract is anything but smart. In fact, it is pieces of codes behind it. It will execute whatever you program inside a smart contract. So I choose to use the word programmable ledger. So in a blockchain, besides records being distributed, you can embed rules in the blockchain that allows you to execute certain transactions if the rules are met. Right? For example, if in a delivery scenario, in a supply chain scenario, when goods are delivered and you have somebody authenticating that I have received the goods, payments can be made immediately, right? Without people going to raise an invoice, doing a three-way match in an ERP and so on. So that attached set of rules can govern how a blockchain ecosystem works. And this is important because in a lot of these large ecosystems, you will want rules that are applied consistently throughout as well. And people will have to know this set of rules before embarking on a blockchain and know that these rules are indeed what people set it out to be. Okay, so that's the second area. Besides being distributed, there's a programmable ledger or smart contract within a blockchain as well. And the third and final area is that a blockchain has obviously a set of consensus algorithm. Why is that so? Because by virtue that it is distributed, you need ways where the participants in the blockchain network agree to accept transactions into their blockchain node, right? So, and there are many ways that this consensus algorithm apply. In Bitcoin, it's called proof of works. There are other algorithms called proof on stakes and so on that's being tried out in other blockchain networks. But this consensus algorithm allows the blockchain network to be collusion proof, right? It makes fraud a bit difficult, but there's a catch somewhere, so I'll come to it in one of my points later, right? So you will hear a lot about blockchain being immutable. You will hear a lot about blockchain being very difficult to hack into, right? But is that always the case? All right, I will come to that later. So these 3 points that I have about the 101 of blockchain essentially gives it a very strong foundation where businesses can come together and bring transactions together, operating very complex logics, right? It requires very few intermediaries or no intermediaries at all. So one of the key benefits then you will hear about blockchain, and in the use cases I will share right after this, is that you will find that it uses, because of the lack of intermediaries, it is very useful in peer-to-peer kind of transactions. So those use cases that are applied typically have many business partners, but you want to work together without the need of an intermediary. Okay, so let me now then move into a few of these use cases where we are starting to see blockchain as a technology being applied in different applications on an industrial scale. The first one is what we call Tesseract. It's for asset management. In fact, this is a very interesting use case. When it's first thought out, it was meant as a record for driverless vehicle. So we have some research going on in Europe on automated vehicles. So one of the thinking behind a driverless vehicle is, do I really have to own a vehicle if it can take me from point A to point B, and 90% of the time my car is sitting in the car park lot. So when it comes to a driverless vehicle, in fact, I do not have to own a full car, right? I have to own it on a period of time where I need it as well. So that thinking come about, can we have an asset sharing or a vehicle sharing ecosystem where people can own a part or a fraction of a vehicle? And that doesn't apply to just the vehicle itself, right? It applies to, for example, the road tax you have to pay. It applies to the insurance that you have to pay as well for the vehicle. So, and this use case came about, right, where we have blockchain as the underpinning record for asset management. We started the use case application for farm equipment in Australia, where a lot of tractors, where farmers and farm owners, in fact, use tractors for only a period of time. And these are expensive equipments. And unless you have very, very large acres and acres of farms, small farm owners typically find it very expensive to own a whole equipment on their own. So what we did was we started blockchain as an application where different farm owners can own part of a vehicles, including the financing portion of it, right? So we started with farm equipment, and it can be applied, in fact, on any large assets that you want to share across different parties. The next use case is used for supply chain. So we are working with Schneider Logistics. Obviously, if you think about logistics, from an end-to-end, from manufacturing to distribution to eventually landing in the retail warehouse, there is many touch points across the supply chain. And these touch points, every single entity will have its own system, either an ERP system or an operational system. And these systems, in fact, track its records on its own. So it's always very difficult to track an asset or track an inventory as it gets manufactured and move through the supply chain to where it eventually lands. So one of the very large applications of blockchain is as an underpinning technology to record these transactions as it moves along. A very common question to ask is also then, with blockchain, does it mean that I do not need my ERP system? I do not need my warehouse management systems today? In my point of view, typically no, right? So the ERP systems that we have today has a lot of features and functions that are very standardized, right? That are, over the years, has evolved to be such a common best practice that it is embedded in our processes. And I don't see a benefit of trying to rip out these functions and trying to build them from scratch on the blockchain. So your ERP and your warehouse management tend to still be useful when you have operations within a company. And within a company, this will continue to be processes that's embedded on ERP. But when you talk about cross companies, like in the case of a supply chain, where there are many different points in an ecosystem, many entities in the ecosystem involved, so blockchain is a powerful tool to serve as an underpinning technology. One of my favorite use case is on wine blockchain. This we did with an Italian wine company. Obviously, wine making has many parts of the process, like supply chain as well. You have to track where the farm is. You have to track where the wine pressing or the manufacturing of the wine is, to the fermentation, eventually to the distribution as well. And the business objective of this use case is very, very simple, because the producer produces perhaps 2 million bottles of wines every year. But in the market, you might see more than 2 million, 3 or 4 million, right? Because of counterfeits, because of people putting bottles, taking the company's name. So the intention is to be able to make counterfeit difficult by putting wine, every bottle of wine that is being manufactured on a blockchain. So the tracing, in fact, is done through a QR code that we embed on the bottle itself. At a retail store, when the consumer buys the bottle of wine, there's a QR code that you can scan, and it tells you which farm did it originate, did the grapes originate from, where is it being pressed, eventually which distributor is supposed to end up to. And you can think that if you scan that bottle, that bottle isn't supposed to be where the retailer is, there's a likely tendency that it's not a genuine bottle of wine. And one typical question that we get is that if the bottle of wine, if I consume that bottle of wine, and I put in Ribena or some grape juice inside, does it prevent that from happening? Answer sadly is no, right? So blockchain is not that advanced to be able to prevent people from replacing real wine with fake wine. But however, if you know that that bottle doesn't come from where it's supposed to be, it's likely to be fake, right? So it does prevent or makes counterfeits more difficult, but it doesn't stop counterfeit totally. So this is live again. It's a use case that we have in Italy that is already in production. The other use case is for government, the city of Vienna. So the city of Vienna has a lot of data that it shares with the public. They call it the open government data. And one of the attributes of blockchain is that the records that you store on the blockchain is secure, right? Because any changes to it cannot be made directly on the blockchain. You have to append to it. So it gives that traceability as well. So for documents that are to be authenticated or notarized, this is a very good use case. The city of Vienna put all their open government data on a blockchain. So it's for consumption by the public. It's for consumption by government entities as well. We know the authenticity of the document because once it's recorded on the blockchain, it cannot be moved. It's been live just since December last year. And one big area as well. So one of the big things EY is doing is to develop a blockchain analyzer. So more and more, as a company moves data onto the blockchain, how do we know data on a blockchain is equals to what is in the real world? And because it's a distributed record as well, it's a distributed database, you'll find that it's very difficult to reconcile. So the blockchain analyzer is a tool that we developed. We want to help clients audit as well records, not just on their ERP system, to make sure that if you use blockchain or if you're part of a blockchain ecosystem, we are able to reconcile their records as well. And finally, one of the biggest implementations that we have is for a royalties management system. So we did this with Microsoft. You know that Microsoft has Xbox machines, and the software the software provider, in fact, is given certain royalties based on the usage. Before blockchain is around, the reconciliation of the amount of royalties due can take up to 60 days. And because of the records being on blockchain, we now have records near real time. So from 60 days, you are cutting it down to perhaps 2 to 3 days before we can reconcile the records. And this use case is one of those that has massive, millions of transactions per second. It brings to the point that, in fact, if you're worried that blockchain has limitations in performance, one of these use cases is going to dispel that. So my next point is, what's the catch then? Since blockchain has been starting to be applied this year in large-scale industry, so what's the worry about? What you should watch out for when you're looking at implementing blockchain? First of all, it's still a foundational technology, right? If you think about it, back to my first point, it's a database, it's a distributed database, and as with any foundational technology, it's not so easy to implement. Companies today have their ERP systems. If you need to rip it out and put new logics into it through a blockchain, it's going to take time. And as such, even the industrialized applications that we look at today will take time for it to evolve before reaching a scale that that is for full-scale adoption. The other point is on a multi-party ecosystem. With any blockchain technology, it tends not to be used for a single entity. In fact, if it's for a single entity, I will question, why do you need blockchain? Can the ERP or your current operational system serve as well? And for a multi-ecosystem, obviously, you need parties to come together. You need alignment on policies, regulations. You need alignment on how the process is going to work, and that's going to take time as well. So typical blockchain use cases start with 2 to 3 entities, and they start to scale after the 2 to 3 entities have sorted out certain 101 criteria. Big topic as well, right? As we start, people are investing into it. You see a lot of small startups getting funding to do this as well. But as we scale as well, right, if it's going to be a system that everybody uses, who's going to fund it? So that's going to be a key topic as well. If you go into large ecosystems of blockchain people, so how are we going to get the funding, and is that sorted out or agreed upon before you go into an ecosystem? And there are major transitions ahead, right? Because it is a new technology, and you see that there are evolutions of new coding standards that's coming into it. So as we see, for example, many private blockchains being applied as well. How do these private blockchains come together? How do they integrate? In fact, my view is that there's going to be a shift more from moving from private blockchains to more public blockchains so that interoperability is not an issue. Currency is a problem as well. A lot of use cases talk about closed ecosystems. You can't do that unless payment is made through blockchain as well, and obviously, companies are not willing to make payments on cryptocurrencies when it can fluctuate that greatly, right? So there is a need, in fact, of moving fiat currencies on blockchain, and I think that that's starting to happen this year as well. You see US dollar being embedded on blockchain, and with that, you can actually have closed-loop ecosystems where payments can be made as well when smart contracts are applied. So some of these hurdles, I think, still need to be crossed. And if you are participating in a blockchain initiative or an ecosystem, it's worthwhile looking at some of these points as well. So what's next, right? Over the past 2 years, we have seen multiple blockchain projects taking place. So when I started this discussion maybe 2 to 3 years ago, there were a lot of POCs. POCs are proof of concepts or trials that people are using. But this year alone, 2018, that 5 or 6 use cases I've spoken about, they are live production systems. They are pilots, they are going out that's in production as well. So things are getting to be industrialized and moving into production grade. But however, blockchains are not for everybody, right? I think that in the earlier days, there's so much grand visions about blockchain that you would think that, hey, it seems to be able to solve world hunger at some point as well. But not so, right? So we shouldn't put the solution before the problem, right? You should look at the problem first, and we have about 5 points that are used to identify the problem. So, and part of the problem may be solved using blockchain, but many a times it may not be, right? Because putting a difficult technology, like a complex technology like blockchain, might introduce other areas that you might not consider as well. So these are the 5 points that we use whenever we evaluate a problem to see, should blockchain be part of a solution, or should other technologies be used as well? Finally, our global landscape of blockchain service centers or hubs that we have. So Singapore is one of our key blockchain hubs in Asia as well. Over 100 different client projects I have mentioned have actually done blockchain type deployment already. So I've come to my final slide. I understand it's going to be a break later on as well. I will be happy to take any questions further on during the break as well. Thank you, everybody.